Hey, it's Ken. This is definitely going into the random thought pile. I've had this thought about gravity for a while now, and it's sort of one of those things that I'm ill-equipped to explain, and it's definitely not based on math. It's definitely not based on anything probably intelligent. But the concept that two objects are attracted to each other, to me, doesn't sound right. And I say this because I started thinking about the universe and how the universe expands. And well, let me just sort of walk you through my thought process. So take a big balloon, completely circular, and in the middle of it, put a super dense amount of mass. And then what I want you to do is then explode that mass out. So Big Bang, right? Great. What happens is that mass is gonna, and the force around it is gonna explode out. The balloon's going to expand. And now you have two forces. You have a force that's pushing outwards from the explosion, and then you have the outer boundary of the balloon that's pushing inwards because it wants to collapse back down to where it was. So I think of the balloon as an infinitesimally small point or dot, and that's a reality. That dot's a reality. And what happens in my mind, at least, is that you have a rupture between that reality and another reality, and the other reality is flooding matter into this vacuum of the new reality, causing the new reality to expand the same way that that balloon would expand. But the reality has an outer boundary. That outer boundary is being stretched. It doesn't want to stretch. It wants to collapse back down to its original form. So now you have this huge explosion because you have all this injection of matter in, matter and energy, same thing, but call it matter and energy, exploding outward. And you have the outer boundary of this reality pushing inward. That push inward to me, gravity. The push outward is one of the forces. Weak force, strong force, take your choice. I'm not great at that stuff. But so you have these two opposing forces. And the push outwards to me is your space-time continuum. And the push inward is gravity. So I don't think you're going to have necessarily two objects being attracted to each other. You're going to have the pressure, because that's what the inward push is pressure. The pressure is pushing everything together because it wants everything pushed together so it can consolidate it down, make its overall volume smaller, and eventually, if it gets its way, it's going to push it into a dot. And the other side, if the explosion is big enough, balloon pops, reality pops, probably all sorts of bad things happen. But I bet you gravity goes away at that point because your outer boundary of reality is now exploded. So then this becomes an interesting sort of foray if you think about it, because now if gravity isn't two forces magically attracted to each other, but it's really pressure, then at the very, very, very small level, you should start seeing shadows. Big object, really, really tiny object, shouldn't have any pressure on it because the big object's shielding it. Well, those big objects in this case aren't planets and asteroids and things. They're nuclei of atoms, and maybe even subatomic particles within the atoms. It could be a proton, it could be a neutron, it could be an up or down quark. So what's smaller than that? Well, I don't actually know, but I have postulated before that electrons aren't really anything but tears in the space-time continuum, or these little tiny shadows that appear without volume. And so you have these tears appearing between two nuclei. The bigger the nuclei, the more the shadow effect you're going to get, and the more these electrons appear. And these electrons, to me, are just vacuums or the absence of the pressure. And so you're getting what appear to be particles or dots or electrons are always thought of to be in two places at once. Well, two places at once, of course, would be a tube, right? And in between the tube is this lack of pressure or the lack of gravity, and I think that then would define an electron. So that ties gravity, which I now think of as pressure, and electrons, which I think of these tears in the space-time continuum, which if space-time is the push outwards, then these shadows, which would be the lack of the force inward, would cause those sort of vacuums in space, so to speak. I don't know where any of this is going. Don't know if it's remotely mathematically valid. But I thought it was an interesting idea, and it sort of feels right. I mean, go back to the balloon. fill the balloon now with those same particles, explode it outwards, but instead of the balloon being empty, it's not going to be filled with the energy that's being exploded outwards, that pressure, and that pressure is all the energy in the universe that we can't see. And then the scientists are struggling with dark matter and dark energy. They're like, oh, we can't see this stuff. It's there, though. Maybe it's not. Maybe it's just the pressure from the outer boundaries of reality pushing back on us. It would be a massive pressure. It would take up 99% of everything we see or feel when we measure gravity. But it's not two forces attracted to each other. It's two forces being pushed together by a much more massive pressure, which is this pressure of the universe created by the outer boundary of reality. All right, I think I've sort of gone off on this weird tangent enough. Got it out there. If anyone's listening or watching this, be very curious what you think.